I can get into the class. Okay. So just an overview regarding last class, okay, of lecture 2. So in the lecture 2, what we have seen is we have seen about the theories regarding the lightning. Okay, so we have seen about the effect, what happens when lightning happens, and then the charge formation theories. So two theories are there. One is your Wilson theory, followed by the Simpson's theory. So these two theories we have seen. So in both the theories also, what we have come to a common conclusion is that uh, your charge separation. Okay, so how your charge separation will be, we have seen. Okay, so in both the theories also, what they are implying is that the charge formation will be having the negative charges at the bottom. Okay, the negative charges at the bottom, followed by your positive charge at the top. Okay, so that's what they are implying in both the theories. But in your Simpson theory, also what they are saying is that depending upon the region of the charges, okay, it depends upon your humidity and your pressure. Depending upon those things, your charge separations varies. Okay, they're also implying in that format. But in general, your cloud will be having negative charges at the bottom, followed by the positive charges at the top. Okay, so this is what we have seen in your previous lecture. So in today's class, what we'll be seeing is regarding the lightning mechanism. So with this lecture, the lightning will get completed. Okay. So with this lecture, the lightning will be over. So after that, we'll be switching over to your surges. Okay. So this is the only external factor which will be affecting your transmission line. Okay. So in today's class, what we'll be seeing is lightning mechanism. It's a very very important part B question. You can expect this lightning mechanism. Okay, so in the first unit, regarding the first unit, there are some specific questions, nearly around some 4 to 5 questions are there. If you are studying those questions itself, you can surely attend your part B question, part B. Okay, so this is the first thing. So lightning mechanism we will be seeing, followed by that some definition. We'll be going with some definition. Okay. So these definitions are some are familiar to you, some are new to you. So I'll just cover the only the definitions which are new to you. Okay. So we'll be going into the lecture. Okay. We'll be moving into the lecture. So lightning mechanism. So today's class will be seeing how the lightning happens. Okay. So before getting into this concept, I just want to ask a question. So regarding a rainy day, okay. So in a rainy day, so you can see the clouds. The clouds will be of dark and will be ready to pour down. Okay. So the thing is, you might be seeing lightning. So my question here now is, so which will be traveling faster? Okay, so you already know that. You just answer in the chat box. So either the lightning or the sound of the lightning. So which will be traveling faster? So you can, any one of you can unmute and also you can reply, or you can just put in the chat box. So which quantity travels faster? Whether it is lightning or the sound of the light.
Lightnings.
So lightning. Yeah, fine. So the answer is right. So lightning travels faster. So can anyone reason it out why it travels faster? Can anybody reason it out? So in a rainy day, first what you'll be seeing is you'll be seeing the lightning strike first. So after the seeing the lightning strike, to 4 to 5 seconds after that, you'll be hearing the sound. Okay. So what is the difference in there?
Sir, light travels faster than sound, sir.
Yeah, right. So, as per the basic principles of physics, your light will be always traveling faster than the sound. So, your light travels at the speed of 3 into 10 power 8 meter per second. Okay, so it is a very high speed. So, regarding that, your lighting will be always faster. So, after that, only you will be hearing the sound. Okay, so it's a general fact, and now we'll be getting into the mechanism of lightning. Okay. So in last class we have seen about charge separation, right? So how the charge gets separated in a cloud. There are positive charge, the negative charges. So how those charges gets separated by the cloud in a cloud we have seen. So now we will be seeing how the lightning passes to the from your cloud to the earth. Okay, so that's the concept we'll be seeing. So while taking transmission and distribution itself, I have said, okay. So if you are standing below a tower, okay, if you are standing below a transmission tower, so you won't be electrocuted. Okay, you won't be electrocuted. So can anybody reason out why you won't be getting any shock or electrocute? Can anybody say what's the reason? ஸோ உங்களுக்கு வந்து ஷாக் அடிக்காது. நீங்க வந்து ஒரு டிரான்ஸ்மிஷன் டவர் கீழே இருக்கும்போது உங்களுக்கு வந்து ஷாக் அடிக்காது. ஓ, கேன் எனிபடி சே த ரீசன்? Just type in either in the chat box. Okay, I'll just move on. The reason is that why you won't be electrocuted or you won't get shock means you are a conductor, okay, but air will be always acting as an insulator. Okay, so air is an insulator. So that's the main reason uh, why you won't be electrocuted. Okay, so air, yeah, always act as an dielectric medium. Okay, so that's what here they have given. So imagine this air as a dielectric medium. So air as a dielectric medium. So the clouds will be having some charges. Okay, so it is one plate of your capacitor, and the earth will be having some charges. Okay, this is another plate of the capacitor. So what happened is between these two capacitor plates, so between them there is a dielectric. Okay, so this acts as a perfect capacitor. Okay, so that's the reason. Okay, so now what you have to do is, in general, in order to see the lightning, this dielectric medium has to be broken. Okay, so this dielectric medium should be able to conduct. If it is able to conduct means your negative charges. Okay, so the negative charges in the cloud, as we have seen in the previous lecture, so your lower part will be having your negative charges and the earth will be having the positive charges. Okay, so with this concept, what happens is, in order to have a discharge part, this center, that is the middle air medium, has to be broken. It has to conduct. Okay, so if it is able to conduct, the electrical discharge happens. Okay, that's what they say. Lightning discharge will require the function of the air between the cloud and the earth. Okay, so that's the concept. So I just want to say a thing that whoever Naveen please uh, use the chat box for only response to my questions, because this entire meeting is recording. Okay, so it will be seen by HOD sir as well as principal sir. Okay, I will also be putting this recording in your Google Classroom also. Okay, so just use the thing for response. Okay. So now we'll be resume the lecture. Okay. So as I said, in order to punch, in order to have a perfect discharge, the light, the air medium must be able to conduct. Okay. So for that, the breakdown of air. So to break down the air, there is some condition. Okay. At STP refers to standard temperature and pressure. Okay. STP refers to standard temperature and pressure. So the electric field required, some amount of electric field is required. Okay. So that electric field is 30 kilovolt per centimeter. Okay. So for 1 centimeter, okay, for 1 centimeter, the voltage around this air must be around 30 kV. So this 30 kV will be given through the charges in this cloud. Okay. So in the cloud, where the moisture content in the air is large, okay, because of high altitude, this I have already covered in the last lecture. So if you are going high altitude means your pressure gets lower. Okay, just seen that for breakdown of air, the electric field record is 10 kV. So here this 30 kV they are saying for around the uh, earth, okay, around the earth surface. Okay, so this 10 kV there is enough when it is for very high altitude. Okay, that is at a very high uh, regions like hill stations such like that. Okay, so after the gradient of that is after applying 10 kV per centimeter, in general what happens is the air will get ionized. Okay, so first there will be negative charges at the bottom of the cloud, so it will be inducing some voltage for 1 centimeter around 10 kV. Okay, so which causes ionizing the air particles. Okay, the particles around the air. Okay, so now the lightning gets started. So I have already said in the first lecture itself that in order to have a lightning, there must be a upward stroke, okay, from the cloud as well as a return stroke from your ground. Okay, when these two gets joined, we'll be getting a perfect lightning. Okay, so similar to that, at this thing, a streamer starts from the cloud, okay, towards the earth. Okay, it's shown in your A diagram. Okay, that is the first diagram. Okay, uh, so this cannot be spotted with your naked eye. Okay, only when you are getting a perfect lightning alone, you will be able to see with your eyes. Okay, so you have to take this stream. So this stream, that is the stream in your figure A, is said to be a pilot stream. Okay, so now you'll be seeing the characteristic of this pilot stream. So how your pilot stream will be? So this pilot stream will be of very high current. So I have already said. So here they have given order of 100 ampere. Okay, so if they're giving 100 ampere means it will be 100 amp. Okay, if they're giving order of 100 ampere means it will be around 10 power 100. So you have to take like that. Order of in the sense means it will be 10 power something. Okay. Next is the speed of this pilot stream will be around 0.16 uh, meter per microsecond. Okay. So just imagine 0.16 meter for 1 microsecond. So micro in the sense 10 power minus 6. 10 power minus 6 second per 1. 10 power minus 6 second, the speed will be 0.16. Just imagine how speed this value will be. Okay. So it is called as pilot stream. Why in the sense means it is a starting point for your lightning. So it is called as a pilot stream. Okay. So next we'll be seeing about the next thing, that is depending upon the state of ionization. I have already said in order to ionize the air, you must need a voltage of 10 kV per centimeter, 10 kV per centimeter in your.
Sir, voice audible, sir.
Okay, okay, this way. So I am audible, right?
Audible, sir. Audible, sir.
Okay, okay, fine. Yeah, I have left over here. Uh, okay. So pilot streamer we have seen. So next is the ionization state. Okay, the particles around the air gets ionized. So and this ionized air forms another one uh, path. Okay, so it is called as stepper ladder. Okay, so this stepper ladder you can see in your D figure. Okay, that is your second figure. Okay, so this ladder steps are of order of 50 meter. Okay, in length. Okay, so this gets starts to grow. Okay, the length of this lightning leader starts to increase slowly. Okay, so now it is around 50 meter. Okay, so this also travels with the microsecond speed. Okay, so next is the charge is brought from the cloud through the already ionized path. So now you have to see through your uh, C diagram. Okay, so that is in a B diagram, the negative charges will be started to flowing through the leader. Okay, so that's what will be. So that's what you will be seeing in your B diagram. Okay, so what happens is once the stepper leader has this start to increase for each and every 50 meter. So when it is coming in contact with the earth, okay, when it comes in contact with the earth, what happens is there will be a return stroke. Okay, this return stroke will be moving faster in an upward direction. Okay, now we have to see is that so there will be some negative ions in your leader. Okay, this negative ions will be trying to attract the positive ion. Okay, so there will be already the positive ions induced in the earth surface. This positive ions will be also attracted to the negative ions. Okay, so that's what they have shown in the C diagram. Okay, so this will be forming the return stroke. Okay, when these two things comes into contact, this forms your return stroke. Okay, next is this streamer is very intense. Okay, they are giving the characteristics of the return stroke. Okay, so how it will be? So this return stroke will be between 1000 amps to around 2 lakh amps. Okay, so the order is increasing. Okay, and the speed is about 10 percentage of the light. So you already know the light speed of the light is 3 into 10 power 8 meter per second. So in that 10% in the sense means how fast it will be. So you just imagine like that. Okay. So this thing we have seen in your C diagram. Okay, this positive charge will be moving towards your cloud to neutralize the negative charge. Okay. So it is here where the negative charge of the cloud is being neutralized by the positive. Okay, as I said in the previous slide. Okay. There may be another cell of charges. Okay, that is the diagram E. Okay, up to the D is your the lightning what you have already know. Okay, there will be a return stroke, and the return stroke gets joined with your streamer to form the perfect lightning. Okay, so after this, what happens is there will be still some charges in the cloud with the negative in the other portion. That is the opposite portion. Okay, so what happens is this charge cell will try to neutralize the through the ionized path. Okay, so that's what they're showing in your E diagram. So there will be some of the negative charges over here also. These negative charges also must have to be neutralized. So this positive charges travels up to the end of those negative charges. Okay, so this velocity of the this streamer is known as dot stream. dot leader. Okay, so this part is called as dot leader. The effect of dot leader is much more severe than the return stroke. So this will be having a very high impact when compared to your return stroke. Okay, so the discharge current in the return streamer is relatively very large. Okay, the current is very high. Okay, that's what they're saying. The energy contained in this streamer. So here what they're saying is they'll be classifying the streamers. Okay, so the dot leader is known as a hot lightning stroke, whereas your streamer or the return stroke is called as your cold lightning stroke. Okay, so why they are calling like that means in both the things the current amplitude will be very high, but the time period differs. Okay, for the dot leader, the time period is very smaller when compared to a normal streamer. Okay, so that's the main difference over there. So next is some of the basic definition that you have to know. Okay, so some of the basic definitions. So first is the back flashover. Okay, so first you have to know what do you mean by uh, back flashover. Okay, so regarding the lightning mechanism, this is around you have to write. So the main part is you have to draw these six diagrams. If you're drawing this six diagrams itself, you can write the story. Okay, so you have to write step by step. First, there's a formation of ions based upon those two theories. Then it gets segregated. So then the pilot streamer is formed. So next year, leader will be forming. Then the return stroke will be coming out. Then finally, your dot leader will be forming. Yes, you have to uh, write in a story format, but with some characteristics. Okay. So next is the basic definitions. You'll be just entering out. Um, so first is the back flashover. Okay. So flashover is nothing but it is also similar to a lightning only. What is that? There will be somewhat sudden spark-like parameter. Flashover of insulation resulting from lightning strike to part of a network or electrical installation that is normally at ground potential. Okay. So this back flashover, how it is caused is this mainly caused from a lightning strike. So that's what they're saying here. Next is the blind spot. So blind spot is nothing but a limited range, okay, within the total domain, which will be visible to your eye. Okay, so blind spot is nothing but the region which is not visible to your eye is called as a blind spot in general. Okay, so that's what here also they are saying with respect to your protective device. Okay, so these definitions are not important, but you have to know what is the okay the strike, direct strike, a strike impacting the structure of interest or soil. Okay. The next is the energy deposition, failure mode, leakage current. Generally, you already know any current, including capacitive coupled current, that can be conveyed from accessible parts. So these all you have already studied. So final is the lightning protection system. Okay, so regarding this, it is also a separate part B portion, lightning protection system. So this I will be covering in the next week. Okay, next week I will try to complete the first unit. So lightning protection system. So it is nothing but not to protect from your both internal surge as well as your external surge. Okay. So open circuit voltage response time, the short circuit current, this is all common thing you already know. You just read through it, but over here the important thing is the leakage protection system, which I'll be covering the really important question. Okay. So what they'll be asking from here is they'll be asking about lightning mechanism. So what do you mean by back flashover? They might be asking. Other things are open circuit voltage, short circuit voltage. So the normal need will be covering it. Okay. So with this, this lecture gets over, and